welcome to day 19 of Leetcode MayChallenge. Today we have question number 329, longest increasing path in a matrix. In this question they have given us m cross n integer matrix and we have to return the length of the longest increasing path in a matrix. And we can move in 4 directions: left, right, up or down. We cannot move diagonally or cannot move outside the boundary. In example 1, as we can see, this is 3 cross 3 matrix. The length of the longest increasing path in a matrix is 4, that is from 1 to 2, 2 to 6, 6 to 9. In example 2, the length of the longest increasing path is from 3 to 4, 4 to 5 and 5 to 6. So it's 4. Let's understand the same question from this example. The length of the longest increasing path in this 3 cross 3 matrix is 4, that is from 3 to 2, from 2 to 3, 3 to 7 and 7 to 9. There are many ways to solve this question, but here I am using the Dfs approach, where I'll be traversing from each cell and will be finding the longest length of the longest increasing path possible from this particular cell. So let's start it. First we are on the cell 0, 0, and from here we can move in 2 directions, that is to here, to the right of it and down. We cannot move to the left of it and to up because it will be out of bound. We have to move inside the boundaries. So the direction we can move from this cell is to 9 and to 7. Now we have to see, like, is 7 greater than 9? No, 7 is not greater than 9. Initially this both are not making the increasing, longest increasing path from 9. And is from 9 to 9, is this increasing? No, they are equal. So the longest increasing path from this cell is 1, that is 9 itself. And now similarly we will move for the other cells. Okay, so we can move, let me repeat this again. We can move to this cell and we can move to this cell. But as 7 is smaller than 9, so it cannot form the increasing path, so it will return nothing. And from 9 also they are equal, they are not forming the increasing path. So the longest increasing path this cell can perform is only 1, that is with itself. So its LLIP, that is length of the longest increasing path possible from this, is 1. Now we will move to this other cell. From this we can move to the direction 5 to 7 and to the right of it. From here similarly both are equal, no increasing path will be found, so it will return. From here also 5 is smaller than 9, so it cannot form the increasing path, it will also return. From here also 7 is smaller than 9, so it will also not form any increasing path with 9, so it will also return. So the total length this cell will have is also 1, that is it can form the increasing path with itself. Now we will move to the other cell, that is 5. From here we can move to this direction and from this direction. Now with it can already form the increasing path of length 1. Now from here 8 is greater than 9, so it can form the increasing path of length 2, that is 5 and 8. And from the left side of it also it can form the increasing path of length 2, that is 5 and 9. So maximum of both 2, 2 maximum is 2, so its length will be 2. So that is increasing path of length 2 can be formed using this cell. Now we move to the 7 cell and from here we can move in the direction to its right and to down. It will not form any increasing path with 7, so it will return. From here also they are equal, no increasing path it can form. So here the length from so the increasing path this cell can form is 1, that is with itself. Now we will move to the other cell, that is 7. From here we can move to the right of it and to the down of it. Okay, I forgot to take one case in this. It can go in 3 directions, that is in this, that is right, that is down, and the other direction is up. So it is forming, with here it's not forming the increasing path, here also it's not forming the increasing path, it's coming 0, but over here it's forming the increasing path. So from itself it can form the increasing path 1 and now it's going to 9. So the length is 1 plus 1, that is 2. So the increasing path this is forming is 2. So it's not 1, it's 2. Now we'll move to other cell 7. It can move in all the 4 directions, that is right, left, up and down. From here it can form the increasing path length using 7 and 8, that is 2. 2 is coming from here. From here also it can form 2. 2 is coming from here. From here it cannot form, so 0. From here also it cannot form because 2 is smaller than 7. So maximum of 2 like from 2 and 2 is 2. So the maximum increasing path length possible from this cell is 2. Now coming to 8, from here it can move to down, it can move to up, and it can move to left. 5 is smaller than 8, it cannot form the increasing path. 7 is smaller than 8, cannot form the increasing path. 2 is smaller than 8, cannot form the increasing path. So so the total length of the increasing path possible from this cell is only 1, that is 8 itself. This is what we have to written. So this is 1. Now we are coming to 3. We can move to up, we can move to its right. From up it already have the length, like for 7 it's 2, and for 3 it's like 3, 7 and 9. So basically if 3 is 3 is smaller than 7, so its length plus 1, that is the with itself it's forming the increasing path of length 1, and the other is 2. So the total length increasing path it can form is 3, and from here it's coming, it cannot form because 2 is less than 3. So the answer for this cell, the increasing path that we can form is 3 of length 3, that is 3, 7 and 9. And then we are coming to 2, we can move to up, we can move to its right, we can move to its left. From here it can form the 1, 2 can form like length 1 from itself, and 2 plus 1 is 3, 3 is coming from this side, and 2 is smaller than 3, so from here also it's forming the increasing path. So 3 plus 1 is 4 is coming from this side, and 2 and 2 is same, so nothing is coming from this side. So maximum of 4 and 3 is 4. So the maximum length possible from this path is 4. So this is what we have to written. Of course we will come to this, and again when we will go to this, it can go up or it can go in the left direction. If it will come from here, its length will become 2, and 2 and 2 is same, then we will take the maximum. So the total maximum increasing length possible from this cell is 2, and maximum out of all is 4. So that is what we have to written. This was it. This is how the DFS approach is working here, and the time complexity is normal, like we are just traversing the matrix, so it's big O of m cross n, whatever is the length of the row and the length of the column. Similarly for the space complexity. Okay, so let's do this question. First thing is we have to move in the 4 directions, so let's make the direction array, and this is 0, 1, and then -1, 0, and 0, -1. We have formed it. Now what we will do it like the base check, that is if matrix is equals to null, we cannot find it, we just simply have to return 0, and then we will create, this is row, and that is matrix dot length, find the column length, now again the base check, if row is equals to 0, we have to return 0, if column length is 0, we have to return 0. Done. We are done with the base check, and then what we will do, we will create length of the longest increasing path array. So this is length of the longest increasing path. This array will store the length of the longest increasing path possible from that cell. So it will be a 2D matrix, yeah, not array, it's matrix. M cross n, and then we will make a variable that is max length, and that is what we have to return. Now comes like how we will form traverse, that is using the Dfs approach. What we will do this, so we will loop through our matrix integer j is equals to 0, j is less than n, and j plus plus. Then we will find the current length from that particular cell, and for that we have to use the Dfs approach. We will give our I, we will give our, we will give the coordinates we are on, we will provide it matrix, we will give the total length of the row and the column, and LLIP array, and after that we will compare whichever have the maximum value should come in the maximum length, that is the current length which we got or the length which was already there. And now we have to write the Dfs code, so that will return as the integer. First thing is we need the coordinates we are on, I and j, then we need our integer matrix, then we need the row and the column, and the longest length increasing path array which it will store. So first thing is, if this is not 0, that is it already have some value, then we will that means that length of this particular cell is already, we have already calculated, then we will just directly return its value stored in this, and then we will make a variable which will, okay, we can give its length is like current maximum. So yeah, here we can give current length for every individual cell. Current length, like for everyone they can make an increasing path 1 with itself, so that's why it's initialized with 1, and for others it has to C. So the 1 length is already there for everyone, and then we will move in odd direction. So we will loop through a direction array, and we will find the neighbor on the x for the y coordinate, and then what we will do is, first we will check whether we are in bound, if we don't have to move out of the boundary. So for that we are using this check. If we are going out of the boundary, we simply have to continue, nothing we have to do. And then we will see if the matrix, we are standing on this particular cell, and if our neighbor is having the value less than what we have, then we just have to continue, nothing we have to do, or equal, I will show you which case I'm talking about. Then we just have to continue, that is like if our neighbor is having 7 and 7, we cannot form the increasing length. If a neighbor is like 3, that is less than the value we have, that is 7, so we cannot form the increasing path from this, so we just simply have to return continue. Else what we will do, else in the current length we will put the maximum length, and then 1 plus the Dfs, we will call Dfs for the neighbors. This time coordinates will change, provide the matrix, provide the row, provide the column length, and provide the array, and then we just have to put the maximum we got in our array, then that is what we have to return, current length. Code is done, we are good to go. Let's run it. Okay. Okay. Here I think I should initialize it with 1 because maximum length 1 your okay. What is wrong with it? Okay, I mean it's row and column. I is less than, yeah, I'm using, this is row, this is column. Anywhere else I have done this mistake? Yeah, this is row, this is column. Let's run this again. Okay, it's not max length, it's max length. Oh my god. Okay, this is math. It's typo. Okay. Finally, it's working. Let's submit it. And we are done. Thank you.